Well, hey there, everybody. Chris Beatty's here from Grower Talks Magazine, and I've got a new logo I want to play for you. And there it is. And I want to welcome you to today's webinar, Strategies for Automating Your Fertigation System. It's a big topic and an important one, and we have I believe 4 different speakers today to help us present. And I want to have all of you guys bring yourselves up, unmute yourself, and turn on your video if you would. There they are. You know, it's a big topic when it's going to take 4 of us to actually do the job. Hang on, I want to make sure we've got our participants coming in. They're filing into the auditorium beautifully. We originally had 5 guests today, but John Chandler from Cultivation Excellence was unable to make it due to just having too much work, which is, I guess, a good problem. But we'll have to do without him today. The remaining 4 guests we have are going to cover the bases beautifully. Let's start by introducing them, shall we? And we're going to do alphabetically, and normally that would really leave Al Zylstra out in the cold, but A is for Al. And so let's start with my friend Al Zylstra of DRAMMwater, who's going to serve sort of as our historian today, among many other things. Welcome, Al.
Thank you. The old guy in the group, I guess.
There you go. But Al, where are you broadcasting from today?
I'm in Seattle, Washington. I manage the water division for DRAM Corporation in Manitowoc.
Yeah, and a lot of people don't know DRAMMwater. They know what DRAM watering wands.
Yep, DRAM watering one started about 78 years ago, and about 11 years ago, I came into DRAM and we started a new division, the water division. And I have about 30 years of experience in that, in controls with commercial greenhouses and growing operations.
Beautiful. Well, you do know your way around a greenhouse, that's for sure. So you'll be able to lend a lot to the conversation today. Next up, from our sponsor, Argus, is Mr. Jeff Neff, Senior Application Technician. Welcome, Jeff.
Welcome.
Now, what does a Senior Application Technician do, dare I ask?
My job is primarily I work with a lot of growers, clients, customers. My role is primarily in customer service and commissioning, so I pretty much get their systems up and running. I've been with Argus for a little over 25 years, so I guess that's the senior part. So you have to go above 20 years to get a senior title. But
it's better than emeritus. Or yeah. What was that guy's name who used to work here?
Yeah, exactly.
And Jeff, where are you broadcasting from today?
I'm in Surrey, British Columbia, and physically I'm about 30 feet from the U.S. border, so I'm right on the near the Pacific Ocean and near Washington State, but in British Columbia, Canada.
All right, but you can't come in now. We got this virus thing going around. Sorry, you're stuck up there. Next, representing the real world, not that you, Jeff and Al, you aren't in the real world, but these guys really are. We've got a pair of growers. First up, Eric Culberson, VP of Horticulture for Columbia Care. Welcome, Eric.
Hello, thanks for having me.
All right, our pleasure. And where are you broadcasting from today, Eric?
I'm out of Gilbert, Arizona, suburb of Phoenix. And
what's that giant logo behind your head? It's a sports team I don't know about.
No, Columbia Care.
That is. So what is Columbia Care? Tell us about that.
We're the leaders of medical cannabis. We're bringing novel medications that serve underserved patient populations to market. And we focus on doing that through awesome cultivation and formulation.
And you've got a background in biology and been doing this for 15 years, I read. And Columbia Care has 13 different facilities across the country?
13 cultivation, more when it comes to dispensaries.
But so you're growing in 13 different spots all around the country.
That's correct.
So you have a lot of variety. Europe. Well, and you're in charge of all that, huh?
Yes, sir.
No pressure there. So you've got to know a fair bit about, and I'll say right now, well, let me introduce Chad first. Let's finish up with him, then I'll say a little bit more. So lastly, but hardly leastly, Chad Salute, Director of Cultivation for Kush Alley. Welcome, Chad.
And also Maven Genetics. I oversee 3 facilities here in Los Angeles.
So you answered the first question. Where are you? LA area.
Yeah, LA area, born and raised. So
All right.
I was born in Pennsylvania, but out here most of my life. So
there you go. And describe the facilities that you're overseeing briefly.
Yeah. So you know, we have several different fertigation systems in our 3 facilities. One we do an Argus, and about 10,000 square feet of bloom, so a little smaller than Eric's doing over there, but you know, it's quite a few people, quite a few plants, and over 50 strains. You know, 50 different cannabis strains that we have to tailor unique feedings to.
Gotcha. Now, I wanted to make a point that even though our 2 production experts here both happen to be from the cannabis segment, this is not a cannabis webinar. In fact, I believe Argus reached out to many floriculture growers to participate. They were just too busy. I mean, if you know what the spring has been like for growers, it's crazy. Not that you guys aren't busy too, but thank you for participating. But it really doesn't matter what crop they happen to grow, because the principles of fertigation are all the same, whether you're growing cannabis, calla lilies, petunias, peppers. Am I right, Alan, Jeff? I'm pretty much right.
That's right.
I hope I'm right. If I'm wrong, that's bad. But now a little bit of housekeeping. First off, if you have questions, and folks are filing into the auditorium beautifully, if you've got questions, there's an area where you can, it's called Q&A, I think. You can type that in. I'll be monitoring them as we go along, and if there are any that are pertinent to the topic at hand, I'll grab them right then, or if we can't, we'll save them for the time at the end. And also, I'm going to call up a quick little URL here for you. If you want to watch this webinar again, or if you have to leave early or anything like that, the webinar will be archived at growtalks.com/webinars. So where's my stop share button? There it is. All right, we'll bring everybody back. I believe that is all of my housekeeping. So if you guys are ready, let's dive right into what I sort of want to call Fertigation 101, but we're going to go way beyond that. And I'm going to start out with something I read in an Argus brochure, which I found pretty interesting. It says, it used to be said, the man with the hose grows the rose. Al, did you write that?
No.
No. Now, it would probably be more accurate to say the person, more politically correct also, the person managing a fully automated irrigation system grows thousands of roses. Not so poetic, but much more profitable, says the brochure. And so what I want to kind of talk about, I want to start with you, Al, is define fertigation for those who don't know, and I'm sure plenty of you do, but there'll be some who don't. Define what it is and kind of its origin, if you would.
That's a $1,000 term for putting fertilizer in your irrigation water. And instead of putting a fish, which is what they did when I was a child, they put a fish in with the plant, or top dressing the plant with a slow release fertilizer. It's creating a liquid solution, injecting it into your irrigation water, and delivering your irrigation and fertilizer at the same time. And the origins of it really are back in the early days of greenhouse vegetable growing, and looking for efficiencies for growing cut flowers, for growing roses, for growing bedding plants, looking for efficiencies rather than having somebody stirring a pot full of irrigation water.
Right, and it can be a really simple method. Everybody's used like a hose on, basically excuse me, a siphon.
Yeah.
With a blend going through a regular garden hose with the guy or the person on the end of the hose growing the rose, right? That's still fertigation.
That's still fertigation, as simple as it gets.
All right, so let's take it to the next step then. Jeff, why would we want to automate that process? Let's talk about, the benefits, the drawbacks, because that's really what the topic is about.
Yeah, I mean, it comes down to the benefits. We're looking, now that we have, irrigation, now we have the introduction of nutrients, which we call fertigation. Now we want to do how we do that precisely, meaning how do we provide uniform injection, irrigation to all your crop? Because the idea is we want to improve your overall crop. And now that we have precision in terms of when we irrigate, now we can get precision on how we inject the solutions, both being on the nutrient side and the pH side. Both are critical things for plant growth.
So the downsides to doing it, though. We talked about something that I'd heard, kind of another old adage, because I've been around the industry a while. The best fertilizer is the shadow of the grower. When you're automating things, you're basically taking your control away from it and turning it over to a computer system so you can go and hang at the beach. Isn't that detrimental to the crops?
Yeah, making the system too complex, too prone to mechanical errors is always a potential danger. So we see that oftentimes in the selection of the types of fertilizers, where you're using lots of different types of fertilizers and you want to get that special recipe. So it is a balance between the complexity of the system that delivers that uniformity and accuracy to trying to keep it also simple and having a system that does the checks for you, has the alarms so you can sleep at night or during the day, when your system is running on its own. So complexity, costs in terms of system breaking down or all potential downfalls if it's gone too far. And understanding the capabilities of your system. Sometimes systems are, the grower wants a specific pH at that crop, and they want to change it on a very 0.1, 0.2 level for each individual row. Well, that may not be your system may not be capable of that. So you have to know your system's capabilities as well.
All right, Al, anything you want to add to that? Because you've been doing. Oh, go ahead, Eric. Go ahead.
I was just going to add to what Jeff said. One of the things that we've definitely ran into is that concept, that idea that you implement automation and people get time off. What we try to enforce and reinforce is the time and labor savings that you get from automation is just reallocated elsewhere. It's focused on scouting. It's focused on canopy checks. It's focused on cleaning and organizing. So we really tried to refocus that idea of automation gives you free time into automation gives you free time to use elsewhere in the garden.
Not hanging on the beach. Not to a flat, that's what you were doing. Chad, go ahead.
To follow up on Eric, we used it to add a level of redundancy to our automation. So, instead of just trusting what Argus says or trusting what our fertigation says it's feeding at, we check, we have people scout the pH on the dripper, on the runoff. And, we check Argus every day, or we check our fertigation system every day to make sure. Before, we might be running around doing feeds, where we couldn't get around to that. So, yeah, it definitely frees up time to make sure your system's running perfect.
Yeah. Now, we're looking at kind of a typical system, typical automated system right here. Al or Jeff, you want to kind of describe what we're looking at here for folks who haven't necessarily seen what a high-end automated system looks like?
Yeah, that's a typical Argus rack mount system or multi-feed rack mount system. They just deliver it that way on a rack on wheels ready to roll into place, connect the inlet water and the outlet water and go to town. And that it's all computer controlled. It controls not only the nutrient injection, but it also has all of the outputs in software to control the irrigation timing, however you choose to do that, and inject up to 8 different fertilizer solutions plus pH up and pH down, all in one unit.
Now, Jeff, this looks pretty complicated here. This doesn't look like it's for the typical greenhouse. But let's talk about the kind of the levels of automation that a small grower to a big grower can get involved in. If you're just going from that hose on, or maybe a simple dosatron, and you want to kind of take the next level. Talk about that.
So this is the other side of the spectrum. So this is the opposite of the hose with the simple injector on it. So this facility here does a injection on those tanks on the right there. There's 14 different injection points, and so what we call this is a single element injection system where the user dials in his recipes on a ppm level. So so this is strictly, in this case, research. So if the researcher wants to do specific treatments for their trials, they would use this type of system. This system has, with a single element, as we call it, or the ability to dial in these recipes, this type of complexity comes with costs. The cost of those stock tanks on the right there, they have to be precisely in terms of their mixing every time. They have to be monitored in terms of their drawdowns. There's a lot of potential failure in this type of system, but it does deliver a specific recipe to each crop. That's its benefit. But it's not a recommended system for commercial growers, even though a couple growers actually use it.
Oh, okay. All right. So we're pretty high end here. And this one comes with a guide to show you how to use it, right?
Yeah. So this is the same facility. We did a training at, called the Kwantlen Polytechnic University, and this is the system as a close-up. So this was installed roughly 10 years ago. This was one of our firsts of this particular nutrient system. That particular panel was a slightly an older version of what we currently sell now. So that panel that you see there is what we actually install in our nutrient system rack. So this is one of the one of the beginnings of our full nutrient system. But again, this is our single element injection system.
All right. Well, let's dive back into really that sort of the why question and kind of look. There's got to be some downsides to doing this. Not everybody should automate, especially a smaller grower. Talk about how you know if you should and what to watch out for.
The cost is a big one. I think the big part of a system is there's a lot of flow-driven injection systems out there, and they're really fantastic for delivering nutrients. I would say those would be definitely on the lower cost level. So if you have a small operation, you don't want to go to that expense for a fully automated system. You go with a sort of a flow-driven injection system, but you may want to add in monitoring to it. So you have a monitoring, you have alarming. So if you don't want to jump to the fully automated injection system, go with somewhere in between that sort of meets your budget, and then add in your monitoring just to make sure that your plants are getting fed. Because really, the part of a control system is to keep an eye on your system, making sure those plants are getting water. It doesn't help your plants if they don't have the right pH or the nutrients. Then you're just simply you're watering plants that will not come to their proper growth.
I would say that if we were just running one crop, if we were just doing one strain, this system would probably be needed. But since we are doing about 50 different strains, we need a tailored feeding for each one. We need a different dryback for each one. Each one takes a different environment, so this system works for us. Now, like I said, if we weren't doing that, we wouldn't have this type of system run. It would be just overkill for something like that.
All right. Al, you've dealt with growers for years of all different sizes. How does a grower know when they're ready to take that next step into a truly automated irrigation, fertigation system?
Yeah,
and what would you advise to them?
It's interesting. There isn't a simple answer to that. There's no line that you cross and say, oh, this is obvious to do it now. It's about budget. Like Jeff said, it's a lot about budget. We're talking about equipment that gets to be pretty expensive, into the $40,000, $50,000, $60,000 price range. And that's not just with Argus, that's with other vendors as well. It's expensive. And so budget has a lot to do with it. The level of automation that your operation can tolerate, I think, is a big factor. If you have your watering and fertigation is done by managed by one person and executed by several people that don't necessarily know what they're doing, it could be a time that you could automate that and be able to give instructions, but everything that you want to have done as a grower is done on the computer, and you can track it and obtain the data from it. Size of your operation, it's interesting. I thought for a long time that really only larger operations could afford or justify something like this. And I have a friend in the industry, Lloyd Traven. You may recognize his name. And at the time, he had a pretty small operation. And Lloyd made a statement to me, this is about 25 years ago. He said, really smaller growers can benefit the fastest because they have the most labor to save. If they can avoid hiring one person, that can make a big difference. And
Nailed
I
it, Al.
see Eric nodding his head to that.
Yeah. You know, there was we just ran this exercise, and we have small grows that are 1,000 square feet and things that are 10,000 square feet. It really comes down to the ROI and what your expectation is for that. And something in at least in my industry is a very short ROI on many investments. One employee with benefits is essentially the same as a $40,000, $50,000 system, depending on the state, depending on your regulations and all those other things. So for us, if we're spending 30% of one employee's time watering, we can start to see that payback pretty quickly. And we can see it even faster when we start to attribute the time savings that employee can now invest in canopy maintenance or other things that are value added.
You know, one of the things to add to that, we hear a lot these days about data and science, being science-driven, data-driven, and that's one of the things that's really important in a system like this, is that you obtain the data, and that data helps you grow better, helps you to repeat a success or to avoid a past failure by not doing the same thing again. But on the other side of that coin is a level of sophistication of the operator that's required. When you get to that high-end system that Jeff showed with 14 different nutrients, single salts injection systems, you really almost need to have a lab expert on staff in order to manage the system like that. So going back to your question, Chris, how does a grower know when it's time to switch? I think that's one of the points, when they have enough sophistication in their staff that they can manage a system like that and can benefit by it because of labor savings, because of the benefit from the data, because of the size of their operation. They also have to have a staff that's sophisticated enough and knowledgeable enough to manage a system like that.
Mm-hmm. I was going to ask, what else needs to be in place at your greenhouse or nursery operation before you decide to automate your irrigation?
Solenoid valves for
Facility
one.
maintenance.
What was that, Eric?
Facility maintenance person.
Somebody who really understands the electronics and everything.
Simple electricity, yeah, simple electrical work, plumbing, an erector set. Shoot.
Yeah, I would think you wouldn't go from hose irrigation to automation. You would want drip or booms or some other semi-automated system that you can easily add solenoids to, or that maybe already have solenoids and are working off of, just say, timers, or you're flipping switches or something like that.
Yeah. Yeah, you've got to have solenoid valves in the wiring and the infrastructure to do that. And usually there's some added infrastructure you have to deal with. How many different solutions or recipes, fertilizer recipes, do I want to be able to deliver in a facility simultaneously? Do I want to be able to feed 2 different recipes to 2 different crops at the same moment in time or in sequence? All of those questions have to be answered to determine what kind of infrastructure level that you need to have. But you're right, Chris, you wouldn't go from watering by hose by hand with a siphon to a fully sophisticated robotic injection system and management system.
Yeah.
I want to know what crops, Jeff. Tell me what crops. Is it only high dollar crops like Eric and Chad are responsible for? Are there any crops where it's like, it's just not worth it to automate and put out some Osmocote and be done with it, why even fertigate?
We have irrigation systems, field crops, tree nurseries, and, you name it, any plant that requires irrigation needs automation. Actually, if you go outdoors, you start getting to more complex things like evapotranspiration models and that sort of thing. These are, it's the decision on when to water becomes more of an issue. So yeah, in terms of the crops, in the research side, you've got every crop because you're always studying corn, you're studying wheat, you're studying everything. You get into vegetable operations and flower, they all have their various levels of irrigation and fertigation automation. So there's very few that don't require automation. And one of the points I wanted to bring up, this sort of a follow-up with Al, is the overall design, I think, is critical, because there's a lot of facilities that have very capable facility managers that can build their own irrigation system. But the key is how that system is actually built, how it's put together. And that's where you need to get some consulting design work before you start gluing pipe.
Because you need to know you're delivering the same amount of water to each plant at the front of the bench, the back of the bench, this corner of the bay to that corner of the bay. And that does take a lot of engineering of the system as opposed to just running drip tubes.
Well, it comes down to, I have a well that produces 100 gallons a minute. I have and it pumps to a storage tank, and from there, I want to water these many plants a day. Can I do that with just right out of the well, or do I need an intermediate tank? So all these sort of, how do I manage the capacity of my water supply to what needs to be watered during the day, and how do I deliver those nutrients to each of those individual zones?
Mm-hmm. And Al, I like your story from Lloyd, and it makes good sense. Have you, Jeff, have you heard any similar stories like that, or any hidden benefits that came out of a system that a grower didn't even know they were going to get, and that makes it the main reason they love it so much?
I heard similar comments. I was working with a client in Las Vegas, and they were struggling at the beginning. They got their fertilizers, everything all cleaned up. And he called me up one day and he goes, Jeff, I haven't called you in 3 months. It's because everything is working great and the crop looks great. And you know what? We're spending more time trimming those plants and everything looks fantastic. So it's not just the fact that we're delivering accurate, fertigation. It's the fact that now that they have time doing other duties. So that's just to repeat that comment. But those are the sort of feedback we get. As soon as automation happens, labor gets freed up. That's huge, and that repeats itself often.
Yeah, and at this day and age, I mean, we know how labor is not getting cheaper or easier to find, or any more skilled, it seems, in some cases when it comes to finding somebody who
and dependability, Chris. Being able to show up for work with the sicknesses and illnesses, a machine will be there every day, ready to go.
Yeah. Well, let's kind of dive in, Chad and Eric. I want to hear kind of your experiences. So Eric, talk about, the practical world of what you've done with automated fertigation, how you got into it and where you are now, things like that.
Sure. We still have a couple of sites operating by hand, and in the throes of installing an Argus rack system. We've evolved from hand watering techniques without any type of sensor data to hand watering with sensor data, meaning moisture content, EC, and pH from our substrate. So we're starting to build those data points and employ them in our watering techniques and management. Does the plant need to reach a full dry down before each watering event? Those are different between organics and commercial fertilizers. Your application approach varies. So across all of our different platforms, we've definitely started to implement more technology to guide our water management practices. Yeah.
And what are some of how have you seen at your facilities, how have you seen automation pay for itself in the obvious ways, but also maybe some of those hidden paybacks that you didn't anticipate?
Sure. When you put a hose in someone's hand, you're putting judgment in their hand, and everybody has a different circadian rhythm. Everyone has a different way of counting 30 seconds or a gallon using a flow meter on the end of a hose. You start to remove variability between employees. And when you do that, you improve consistency. And when you improve consistency, you get improved yield and performance, stuff that you can predict and depend on. And that's what we've really been driving. The more we can depend on a consistent approach to the crop, the more we can predict and forecast further out.
Yeah.
And from my perspective, that's a big deal.
That's especially critical in a crop like cannabis, but if you're a plug producer, a vegetable producer where you need to get yields, maximum yield week in, week out very consistently, as opposed to, maybe you can get away with, say, fall mums or a poinsettia crop you know, because you do it once and then you move on to something else till next
You
year.
know, Chris, one thing we noticed that you were asking in specific is water usage. It went way down. We learned a majority of our sites are overwatering, and using these tools like a water moisture meter, you can learn that really quickly.
Did you run into any resistance? Because I would suspect,
Oh, yeah.
especially kind of in your world, you don't have growers, you have cultivators, right? So it's a whole different thing. And some of
Sure.
these of these guys and gals maybe have been growing the crop for a long time in other places, and they're very personal about I know how to water. Now you're suddenly going to let a computer tell me how to water? Talk about that a little bit.
Well, what we do is we rely on peer-reviewed science, and the peer-reviewed science suggests that when you automate fertigation based on moisture content in the soil, and you understand what your crop prefers, the outcomes are just night and day. So when we get pushback, when I get pushback, I quickly resort to peer-reviewed science on tomatoes, peppers, cucumbers, watermelon, C3 plants, carbon-3 plants, how they function, their physiology, and that's very hard to argue with.
All right. Chad, same question to you. What's been your experience over the years?
So a lot like Eric, we came from same thing, hand watering our crops, and you know, moving into drip systems and now into fully automated. It has cleared off a lot of those mistakes that from human error, and we're able to you know, not have somebody say, like he said, this plant has enough water, or now we're able to make a very, very consistent watering, dry back. Look at our analytics. We use a system called GrowSense that measures our water content and our EC. It does not do pH, but we measure our pH through runoff. So now we're able to get these analytics, steer our crop, see the change in cannabinoids and terpenes, and see what improves it. A lot of times we were going just on feel. You know, you pick a plant up and you go, okay, this feels great. Or looking how it droops at a certain part of the day. Or from my standpoint, I did look at other crops like Eric did. You know, because there's the study on cannabis is really kind of limited. So we do have to borrow from other crops to see what worked for them. And I think, you know, we're at a beginning field here with cannabis that we're kind of trendsetters, and we're finding out what works. You know, there's so many different strains out there, so many different levels of this actual. You can't get a seed and say like, oh, this is going to be Gorilla Glue every time like you would Roma tomato. You know, it's everyone's different. So when we get a new strain in there, that feed time, that watering time, what it likes environmentally is different. You know, so. Having these analytics on this automated system really helps.
It's a science experiment every time you grow a crop.
It really is.
Every time.
Is. Yeah.
Well, and what about some of the ways that you've seen automated systems return on your investment beyond just say labor savings or water savings?
I hate saying like Eric said every time, but you know, it was like allocating different job duties that people were doing with feeding and mixing nutrients and doing the reses. It was more going into that redundant factor of having them check on the crop, having them scout, having them looking at our runoffs and inside the plants more than doing the feedings and watering, but actually looking at the crop and scoping them, and more that factor, we can allocate labor into that more, and it improves crop. You know, the more you put into this thing, the more you get out of it, it seems. So it's nice to have those employees, instead of trusting that they're making the mix the right way each time and watering the plants the right way each time, but going out there and inspecting the crop more and giving me those analytics back, and I can check it with what we have on our graphs and make sure it's still there. You know, this is a high dollar crop. It costs a lot to produce indoors, and we have to make sure it turns out great.
At the same time, we saw that picture with the multiple stock tanks. Those have to be mixed really precisely for the system to work.
Yeah,
because it's sort of the old garbage in, garbage out, you know, computer phrase. So your people have to operate at kind of a higher level if they're running the fertigation system, right?
So we did start, I think a lot of cannabis growers, and I know you have a lot of big ag out there, but a lot of us have started with just looking at marketing. So we were fooled by kind of what it said on the bottle, and you get a product that has 16 different inputs, and you're like, I'm going to grow the best cannabis ever. But in reality, it's environment, and it's having I like to say, keep it simple, stupid, and just providing the plant the best environment you can, and then really dialing dry back and EC and pH levels. We went from a rack that had 16 different inputs to 8, now down to 3, and possibly just adding slurries and veg and keeping that crop going all the way through. So that part of it, it really has changed our perspective on growing this crop.
And that's interesting, Al. Automation can actually help you simplify your operation in many ways, because you now know exactly what the crop performs best with, and you can hone in on that instead of experimenting all over the board every week in every crop, right?
Yeah, you watch that, there's a curve, and it starts out where everything is so simple because it is so simple, till it gets so sophisticated that nobody knows what's going on or how to operate it, and you start having problems, and you keep evolving the system until it's back down to being so automated and so well managed that it's simple again. And that's important. We've seen, that's one of the things that I think Argus has probably done as well or better than most companies in terms of the automation, is driving for that simplicity, keeping it simple. I've seen kind of a nexus between what I kind of refer to as the new kids on the block, which is the cannabis industry, and the old guys, the old guard, in the other part of horticulture with vegetable and bedding plants and so on. The cannabis growers came in, and they wanted to have the most sophisticated of everything, and super complex, and like Chad said, 16 different stock solutions and 29 different recipes and all of that stuff. And we've seen them learn that can be a lot simpler than that. But at the same time, the value of their crop has driven a lot of the development. It's helped pay for the knowledge in the industry that now people that are growing less valuable crops, it doesn't mean that they can't benefit from it because it's not as valuable as a cannabis plant, but the technology is there and they can ramp that up now. And the cannabis industry is kind of helping us see how we can do that. So one's ramping up, the other one is simplifying a little bit, and the nexus is in the middle. Mm-hmm. And I think that's important for every grower to find out, is that there is, what is the simplest, best way to get it done, not just the simplest.
Yeah. Jeff, you want to add to that?
I'd like to add to
Chad,
to Al's comment is when we were doing this in the not so legal regulated market, we were using a lot of inputs that maybe you're not supposed to, and now since we're the most regulated market in the world, we have to actually use inputs that the vegetable growers can use and we can't use. So we moved a lot to I think it's helped the overall agriculture is moving to more beneficial fungi and bacteria, and I see a move in that is actually I think better for the world in general, that you're moving away from certain pesticides and certain PGRs that we have to use trichodermas and to kill fusarium instead of Cleary that the tobacco industry uses. So and a lot of this stuff is a benefit that I don't know if cannabis growers driven this because it was always in agriculture, but I see a lot more of it used now.
Jeff, I wanted to ask if you had anything to add to what Al had said about simplification versus complication.
Definitely. I mean, we've seen it in the last few years where the cannabis industry has elevated the designs to very sophisticated designs, to the point where, yes, some cases they have been overcomplicated, but it's coming back to that, off that curve. Fertilizer mixes are becoming more straightforward. We have A, B, C mixes instead of 8 different mixes. So we're coming back to more of that realization. The big driver is cost, because a lot of these specialty fertilizers are very expensive, as well as they're, when you mix some of these solutions together, they react to each other. So there's a little bit of a problem with some of these fertilizers where they reacted in the system and they made a bit of a mess in terms of the biological mess. So a couple of things that were brought up here, I just wanted to quickly touch on. One is the application of treatments being organic in nature or disinfection, and that's more in Al's court there. But that's a critical part of irrigation or fertigation is applying specific treatments when you want it. Say you had a biological thing occur in your irrigation system, fertigation system. How do you treat it? What steps do you do to maintain the cleanliness of your system? And what treatments can you do on a short-term basis to resolve that?
Eric, let me ask you, any mistakes that you've made or advice you'd give to a grower who's thinking of taking that leap?
Yes. Plumbing. Get your drains cut early. Build your site with floor drain and ample supplies of floor drain.
Why do you mean?
If there's one thing that just keeps me up at night is you can put all this irrigation together. You can plumb it to the tables. You can have a beautiful design. If you can't get the water out efficiently, you're left with extra dehumidification on your system, disease, which is a massive problem in cannabis, especially indoor and outdoor, as opposed to something else, I guess. So those two things. So you've got to get the water in, but don't forget how you're going to get it out. And Jeff mentioned cleaning the system. Crucial. You don't want to go too long without having a systematic approach to maintaining the system. There are buildups in the lines that can occur that can change the pH just in the time you sent it to where it gets to the emitter. Biology can have massive effects on pH. So not to mention some of your nutrients can fall out. So you want to look at that and then think about what chemicals are you sending through. Are you using standard chemicals to clean the system, and is it okay for the system? And then what do you have to do to make sure that it's out of the line before it gets to a plant? So you have the system in place. That's step one. But now how do you use it appropriately? So that would be the biggest pitfall. Teams need to think about how they're going to actually accomplish these things using the system as part of the planning stages. Not just, hey, we've got the ROI justified, now let's get it. No, put the whole plan together. How are you going to use it? How are you going to maintain it? Those things.
Okay.
I'd like to add to Eric's comment on that is sterilizing the system. If you're not planning on how to sterilize the system correctly, and you're not employing a purge valve before your feeders, you can add some of that sterilization to your crop and kill your crop. So that was the planning beforehand and getting the system in before is so crucial. Having the drains in place, having the purge valves in place, how you're going to maintain it before you even think about anything about automating is very crucial. And I know when we dealt with when we were building with Argus, it was we added more valves than we probably needed, but we ended up using them on every zone, every purge valve in every zone to send Sanidate through, to send Xylitol through, to clean out the biofilm. We test inside our irrigation lines, and you get something like Fusarium in the irrigation lines, and it could be detrimental to a crop.
And now water's your business, sanitation. So you know this better than anybody, right?
Yeah, the biofilm that grows, any disease, I like to say any disease that you've had in your growing operation is likely to be living in your water system right now. That's the nature of biofilm. And so what Chad said is very important, that the system be designed to accommodate whatever form of disinfection you're going to use, whether that's an injectable material or some other form of treatment like ozone or UV. That's the thing that I've seen most, the most errors that I've seen recently as systems have become more sophisticated. Easy for me to say. As systems have become more sophisticated, it requires a more sophisticated infrastructure. And we see in all aspects of the industry, vegetable bedding plants, cut flowers, in cannabis, we see growers kind of picking a piece of equipment from here and a piece of equipment from here and a technology from over there and trying to cobble it together without really understanding how the systems need to work together. And that's what my division, that's what our company does. So this is an advertisement, free advertisement, sorry. but it is really important, as Chad and Eric have both stated, that those systems the infrastructure has to be designed to work together. And that takes somebody that really understands. Way back when the dinosaurs roamed the earth and I was a child, the grandfather built the greenhouse operation, the growing operation, built the heating system, built the controls, which was a thermostat, built the water system and knew how to do that. And his son probably did too, but now the grandson's running it, or an investor is running it, or somebody that grew up growing in a 500 square foot room is running it. They're not necessarily going to know. They're probably not going to know how to build that infrastructure properly. And that's critical.
All right. I've got two more topics to dive into before we jump into the questions. And there's some really good ones rolling. It's going to be fun to get to those. Other reasons to make the investment, Jeff, like environmental regulations, which I hear are not going to be going away anytime soon. Water, runoff, those kinds of things. Talk a little bit about how automated irrigation can assist with that.
Well, it's the management of the water cycle, and I'll let Al sort of discuss that in a little bit. But yeah, Argus can definitely manage that full cycle, because you're putting the water in. It goes to your fertigation, it gets distributed to your plants, your emitters, goes down the drain. What do you do from there? How do you treat it? How it gets brought back to a tank, and then the whole process can repeat itself. So that's how we can reduce that. Environmental regulations, it varies from jurisdiction to jurisdiction. So you got to be very careful, especially the new build. You got to know what the rules are, because in a lot of places you can't dump that water. Either it may have regulations in terms of what pH level it's at when you put it down the drain, or simply what's in it when you put it down the drain. Something So yeah, it's a huge topic, and it varies from area to area.
Just to pick up on that subject of the last statement that Jeff made, it varies from area to area. We've seen places like the province of Ontario, where they said anything that comes out of your facility, you can't drain it off the waste. You have to keep it or reuse it or whatever. And we see that in parts of California and in Quebec. Mm-hmm. And the most interesting thing that we've seen in the last 10 years, I would say, is we've assumed that a lot of the regulations would just never be enforced. And states and municipalities keep backing off because they're tending to the most recent, economic crisis. We're seeing that stop now. The enforcement is continuing at almost a breakneck pace. And it's easier for states and provinces and municipalities to enforce the law. The law exists in most places. It was created back in 1978 in the US and I think 80 in Canada. And all a city or a state has to do is say, me too. We're going to adopt what that state's doing. And all of a sudden, overnight, almost in a period of 90 days to a year, you can go from not having to or being able to drain to waste to not being able to drain to waste. So I think it's important for every system to be designed so that it can accommodate the ability to recycle the drain water that comes off of the crop, even if you don't put that into the system immediately when you design the system. Have the system designed so that it can accommodate it. that's probably the best reason for, or one of the best reasons for automation when you consider drainage. The rule number one is first reduce the use. And reducing the use, we've seen from studies going back 30, 35 years done by universities like Ohio State and Michigan State, that automating an irrigation system alone, regardless of how you deal with the nutrient management, simply automating the irrigation can reduce the water use by 40, 50, even up to 70%, depending on how you're irrigating now. And so reduce the use first is a very important factor.
All right. Last topic. There's a lot of futuristic things these computers, these devices will do now, but what is next on the drawing board, Jeff?
The part that's been touched on throughout this last hour comes up is data. How do we manage data? How do we feed that data into smart systems that can make decisions for us? How we can use the irrigation fertigation data, one for reporting agencies, say like I need to know what all my inputs are for that particular plant. So now we can use that data. I can use a volume, EC, pH. I know what I fed that one plant. So the raw data that sits in Argus may go into another system that may sort that out. The other part is now we have environmental data tied in with your fertigation data. Now we can sort of use other systems to say, when do we have crop failure? We can predict crop failure. Do we have some smart systems that can say, your system is going the wrong direction. It's not taking up as much water as it normally is, or other readings we're pulling from the Argus system that can give us information. So I think in the future, the control side in terms of automating the fertigation system, the climate system are pretty much standard. That we've done it. Now we're moving to another world where we get into smart systems, AI, artificial intelligence, to help us grow that plant and help us actually oversee your whole operation and say, how do I see where the problems are and how I can identify them and correct them?
All right.
Systems, for example, that would eventually, I think, will be available to see where a crop may be flagging because it doesn't have enough water. That can send an alarm to the control system. Also, the feedback as we get more and more into recovering wastewater or leachate drain water, being able to automatically feed the nutrient balance of that leachate water into the control system and have the control system automatically respond. That is not something that is available now, but the components of that are available now, and we see those coming into play over time.
Yeah,
I was going to ask you, Chad and Eric, I wanted to ask you if you have anything on your wish list. Like, I wish my Argus could do this.
What Al just said, if we could do that, that would be amazing. If we can take our runoff and see what parts we're missing and just add those parts back in, I mean, how much would we save on just doing that right there? So, I mean, yeah, that would be an amazing thing. I think that would be on the top of my wish list right there.
That would be neat. Sensor packages for me. Ways to tie in more moisture sensors, anemometers, so I can see my dead spots and learn more about transpiration rates. So really, for me, it comes down to sensor packages. I want more sensors in my grow.
All right, and I think there's a question from one of our audience members, because we're going to dive right into that right now. If you guys are ready or don't have any final words, let's dive into some of these. And they're kind of all over the board, and some of them are a little bit more basic irrigation questions. But hey, we've got irrigation experts here, so let's help these folks out. And our first question is from Rwanda in Africa. All right, this is an international event, and it involves the cost versus value. Now, we talked a little bit about that, but this person says, I don't think that automated fertigation systems are financially viable on small scale farms because of the investment cost. So they want to know, what's the required project scale in terms of the area and the crop and the value chain where automated fertigation becomes cost effective? Is it even possible to answer that question, or are you going to say it depends?
I mean, the crop matters big time on that. So are you producing top quality crop that can fetch the price to justify it. So, you know, that would be my answer to that. If the crop doesn't justify it, then, you know, you can't do it. But on our end, it justifies it right now.
Yeah, and labor cost as well. I think daily labor cost in Rwanda is going to be cheaper than in LA. I think, Chad, right?
Yeah, oh, absolutely, absolutely.
But
Yeah.
levels of sophistication, right? So they don't have to go with a full sophisticated, you know, Al was talking about some injector systems and they work amazingly. Consistency of fertigation, let's say it differently, consistency of electrical conductivity in your mixture, that alone is a big deal and will return on your a better investment.
Yeah, a simple water pumping system like a dosatron. And I know that Jeff Argus is not afraid to point a customer when they think that that's a better alternative, but a simple water pump injector like a dosatron, and an EC and a pH monitor, a hybrid system. You monitor that physically and you make the adjustments. There's other companies that manufacture automated, much simpler automated EC and that can control EC based on set point and sensor feedback, and pH based on set point and sensor feedback. Those are available for much smaller budgets. So it doesn't require a $50,000 or $60,000 system to get the job done. Scale that to the size of your operation and your budget.
Yeah, I like the idea of using, and that's a great example of in Africa, you know, Rwanda, you may have technologies there that we're not familiar with. Some lower cost technologies for injecting solutions, for your irrigation systems. Keep in mind, Argus is a control system first. So if, as long as you have something we can control that meets your budget in terms of an injection system, then it could be definitely viable for your location. Okay.
We have a lot of questions about sensors. People want a list of vendors. Where do I buy it? Who makes good sensors? We're asking about AC and pH sensors, moisture sensors. I don't know if we can give any real specifics here, but we haven't talked about the sensors used to control these systems. Or talk a little bit about that, if you would.
Well, we use a Grow Sense by Grodan. It measures EC and water content, moisture content. It doesn't measure pH. So, I mean, that's what we use at our facility right now. We had tested out a few different ones that do pH. We haven't actually decided on it yet if we're going to use them yet or not.
I think one of the things with sensors, there are expensive sensors, which usually are somewhat better than the cheap sensors, but all sensors do the job, get the job done. What I've seen with sensors is that it's not so much which sensor you're using, is that sensor placed in the right spot?
Yeah.
In the system? Is it kept clean and maintained? Is it replaced routinely, like a pH sensor, for example, should really be replaced once a year, maybe even more frequently, depending on water quality. And then knowing what is monitoring that sensor. And is it monitoring it frequently enough? Those are much more important than which sensor you buy or who you buy it from. It's getting the information from the experts as to how to install that and use that.
Okay.
I would agree with Al. Your tool is only as good as the hand connected to it. So you've got to understand your tool, and then you can start to make judgments on the information it's telling you.
Yeah, and I would say that probably if you're not growing a good crop with a manual system, an automated system isn't going to necessarily help.
No, it's
Fix
not.
it, yeah.
Probably make it worse, right? If you think that's going to solve your production problems, probably the other way around, yeah?
Yeah, I've watched, I've long said that you can give a bad grower the best equipment in the world and they will still grow a crappy crop. Give a good grower no equipment at all, they will figure out how to grow a good crop.
All the other sensors we use are provided by Argus. I was gonna, the water, the moisture level one's one, but the Argus provides all the CO2 sensors, the PAR sensors, the temperature sensors, humidity sensors. We use their sensors in all of their parts of the cultivation.
All right. Does anybody know what DO is?
Dissolved oxygen.
Oh, I did. Oh, I couldn't come up with that. Anyone?
Yeah.
We've got a couple of questions. Dissolved oxygen and ozone treatment. We've got two people who want to talk about.
I've run tests on both. We use ozone in our operations today, and in a aqueous solution. Dissolved oxygen, it really depends on how you're using it, and if you're looking for improvements in yield, then there are some very specific ways you have to utilize it to realize any improvement. But if you're running a quality grow, don't waste your time on improving your dissolved oxygen content.
I've kind of heard the same thing.
Yeah, we just base our nutrient feed on temperature and the highest dissolved oxygen it can be at it. And that's usually where we'd go at, but we haven't got into the ozone yet. I was researching it on the using it into our solution, but I read about some fallouts of iron and stuff like that. So we haven't really got into it yet.
Yeah, I'm going to have to be careful about what I say because we sell ozone and we design ozone systems. And so I'm not going to.
What's ozone used for, Al?
Ozone is a disinfectant oxidizer. It's the most powerful oxidizer available, and we use it in horticulture for a couple of reasons. One is that it'll kill biofilm, which is the most critical thing to deal with, and it will kill it on contact better than anything else. And number two, it leaves a residual that's beneficial to the plant, which is dissolved oxygen, as opposed to leaving a residual like a chlorine-based product or chlorine dioxide, which is damaging to the root system of the plant. Dissolved oxygen is important. Going back to that question of dissolved oxygen, that is a factor we've known for years, that you measure pH and you measure EC and you look at water temperature and all of those things, but nobody paid attention to dissolved oxygen. And it's interesting that you asked that question, Chris, or that it was posed probably by one of my colleagues.
Testing you.
When we asked that question of growers 10 and 15 years ago, it was interesting. Nobody knew the answer. If I asked 100 growers, one might, and that was probably somebody that attended one of my talks. I'm proud that we've gotten the word out there now because we've played a large role in that. DRAM has, that growers now, not universally, but many, many growers understand that dissolved oxygen is a critical point, and more so, and I think that was, Eric, what you were inferring, the lack of dissolved oxygen is more damaging than the excess benefit of having extra oxygen. The jury is still out on exactly how much benefit that provides, but we know that if your dissolved oxygen is below 6, that's not good, and that's not helping your crop.
All right. Harley asked several questions, and I want to give him a chance to get one of them in, and I want to pick one, but this is a crop question. So this is for Eric or Chad. I think Eric actually mentioned on dryback, maybe on your cannabis crop. Could you comment on dryback strategies for hydroponic cannabis? Eric or Chad?
That's where you're going to want to focus on that dissolved oxygen. You're not going to necessarily dry back. So what I would recommend is look at the osmotic pressures and how to manipulate your ions in the solution versus in the plant. So what you're trying to do is offset the way the physiology of the plant is uptaking its nutrients and its water. Look at your same strategies for fertigation, reducing your nitrogen load at a certain point. Why? It's offsetting other things. Increasing your PK really is what it is. Increasing your PK is offsetting your nitrogen. So there's lots of different ways to manipulate your fertilizers. But in a hydro setup, I'd be more looking at my dissolved oxygen content and playing with the EC at certain times.
All right. And then we're going to get one more question in here from J. Roberto Martinez Morales. Another crop question. Al, this one's to you. It's a nice, simple question. What could be the best method of watering plants in trays in a raised bed in a place with a tropical climate?
The best method of watering in a tray.
Plants in trays, in raised beds, in a place with a tropical climate.
Tropical climate.
Yes.
It's interesting. That's an interesting question because dissolved oxygen is one of the things that we have found plays a big role in that. We've seen a lot of growers in tropical climates try to cool their water because they understand that dissolved oxygen is an important part, or simply getting more dissolved oxygen in the water. In a tropical climate, growing in trays, that water heats up very, very quickly. And when it does, it drives the dissolved oxygen out. When you see water with a temperature of above 30 degrees C or 80, 85 degrees C, there's very little room for oxygen in that water anymore. And that stresses the roots. And that sends a lot of growers looking for other answers. And the real answer is cool your water down, put some dissolved oxygen in it, and you'll probably be better off.
And look at your substrate. Add more air holding capacity, add better drainage.
All right. Well, we're going to leave it at that because we've just gone over the hour, as I knew we would. I always do. I can't stop these things on time, but we're having so much fun. I didn't think to put an email address up, but Jeff, if I share your email address for anyone who didn't get their question answered, you'll answer it. Operators are standing by 24/7, right?
Yes.
It is it's easy. It's jneff, JNEFF at arguscontrols.com. All one word. jneff at arguscontrols.com. And well, guys, it's been fascinating. We could have gone on. The questions really got technical in some places too. I'll share them with you. I'm not even sure. I couldn't pronounce some of the words. That's why I didn't answer them. I asked them. But I want to thank all of our panelists for helping out today, and everybody for participating. Again, if you want to watch the archive of this, I'll get it ready as soon as we're done here. You can go to growertalks.com/webinars. In fact, let me call that. I'll share the screen again so you can get that. Where is it? There it is. Share my screen just so you can see it. All right. That's it. That's where it's going to be archived. And that's really it. So on behalf of Chad and Eric and Al and Jeff and everybody at Argus, especially Alex behind the scenes who helped set this up, and always, as always, my staff at Ball Publishing who work so hard so I don't have to, I'm Chris Beatty saying so long, everybody.
Thank you.
Thank you.
Thanks.